Hey everyone, this is Josh here for Deuces Cracked with the third edition of Applied Math. And the focus of today's video will mostly be constructing ranges using Bayes' theorem, adding weights, calculating equities based on those weights, and calculating pieces of a range and breaking down a range based on those weights. And we'll finally be getting into some real Hold'em examples instead of just that, those one card poker examples, because I know a number of you are getting antsy, based on looking at the comments. So we will, look into that. We'll get into a little bit of the two street analysis. So today's agenda, I figured I'd, cover that before we proceed. First, I'll go into the episode 2 quiz answer where I pose the question, how can, in a given, the one card poker example, how can the villain minimize hero's total EV of a line? From there, I will give a very, very quick lesson in basic poker combinatorics. I could have skipped that. I think most of you probably know this type of thing, but if not, I'll just have a probably about 5-minute lesson. If you do know about, or you do have the solid base in that, you could skip over that. But like I said, 5 minutes, and then we'll introduce weights and Bayes' theorem, calculating ranges, like I just described before, and then we'll get into a real hand example, which will be check raising a gut shot. And looking into the implied odds if we hit on the turn and how much fold equity we have against a range. And then next week we'll start going into, as of now, what I'd like to do is next week start going into the what if scenarios based on this hand example. What if villain is tight? What if villain is loose? What if villain is in on the button instead of the hijack? What if the flop is 3 ways? What if we check raise 3 ways instead of 2 ways? And all those what if scenarios, and I'll show how to tweak our model so we can start adding in these scenarios and really learn about how much of a difference it would make. For example, hijack versus button, him opening from the button versus the hijack. So I'll be right back with the quiz answer for episode 2, and then we'll quickly get into our range construction. So here we have my quiz answer for the episode 2 quiz. And just to say the example again, our opponent bets a range of ace, king, and deuce, and checks the other 10 cards. And the question was, assuming that we make the best possible play available to us and we know our opponent's range, how can he minimize our EV? What type of check call range should he have? Essentially, when he's facing a very good opponent who has a good idea of his range. And the reason why I pose this is because, if you recall, the end of the last video, we went over the scenario where we are out of position, and it turned out that our best check call range was something around half of our checking range should be either calling or raising. And I wanted to get this from the opposite perspective. Now we know that from our perspective against an opponent, we should check call half of our range. So now I want to know what our opponent should do against us, and we should expect, excuse me, we should expect that around half of his range should be check calling. And the reason for that is because he would like to make us indifferent when bluffing. If we're risking $10 to win $10, it's even risk to reward, so a bluff would need to work 50% of the time to have greater than 0 EV. Now it becomes a little more complicated because we have the option of checking, but we do know that it's going to be roughly in that neighborhood. And I filled in this whole table, starting with a range of never folding, going all the way up to a range of only calling with a queen. Now, hopefully you could have expected that the worst thing he can do is never fold or just about always fold, since presumably we would know that that's what his range is, based on this model. So the best thing he can do, from a game theory perspective, is to have a range of calling the 9, 10, Jack, Queen, folding the 6 cards. And keep in mind that when we have one of these cards and we want to bluff, let's say we have a 3, there are only 5 remaining cards. We have a blocker. So it sort of works out to him calling with roughly half of his range, given that we're bluffing. And if you have any questions on this, I'm happy to answer them. I figured this would be, for one, a good exercise in filling out these tables and working with EV tables. And I think these large tables often, for any situation, turn out to be pretty helpful. So it's something that you're gonna see again in this series. So this was your answer, and hopefully you have an idea of how indifference points work and why our opponent would want to make us indifferent from a game theory perspective. So I'll be right back with the PowerPoint and the basic combinatorics. So as promised, I'll give a very quick lesson in combinatorics. I'm going to try to keep it to 5 minutes or less. Feel free to skip past this if you'd like. So pocket pairs. Very simply, take pocket aces for example. You want to know how many ways there are to make pocket aces. There are 6. When 0 cards are exposed, there are 6. Spade heart, spade diamond, spade club, heart diamond, heart club, diamond club. When there's 1 card exposed, for example, I have an ace in my hand, I have ace king, and I want to know how many combinations there are for my opponent to have pocket aces. There are 3. Let's say we have the ace of spades, then he can have ace of hearts, ace of diamonds, hearts clubs, diamonds clubs. And let's say we have pocket aces. We want to know how many different combinations of aces there are. There's only 1. There are 2 remaining suits. I think that goes without saying. So for pocket pairs, we have the rule of 6-3-1. 6 possible combinations when there are no cards exposed, 3 possible combinations when 1 card is exposed, and 1 combination when 2 cards are exposed. This is the type of thing that, once it's in memory, very simple, no math really needs to be involved, but it's important when listing out these tables and enumerating all the combinations. So next are unpaired cards. First we had paired cards, now we have unpaired cards. When 0 cards are exposed, there's 16 combinations. We want to know how many combinations of ace-king are there possible. There's 16. The math behind this, or the computation, is the number of remaining cards of A, so let's say the ace, and number of remaining cards for B, so let's say the king. So number of remaining aces times number of remaining kings. The reason why this is 16 is because 4 remaining aces, 4 remaining kings is 16. 4 times 4. So let's say we have ace-king. We want to know how many combinations there are of ace-king and ace-queen. There are 9 ace-king, because there are 3 remaining aces, 3 remaining kings is 9. And for ace-queen, there are 3 remaining aces, 4 remaining queens, so 12 combinations of ace-queen. Now offsuit and suited cards are a little awkward because there's no real computation. For suited cards, you pretty much count. If you want to know how many combinations of ace-king suited there are, you basically just need to know how many possible remaining ace-king of spades, ace-king of diamonds, ace-king of clubs, ace-king of hearts. So if there's an ace of hearts on the board and a king of hearts on the board, then there are 3 remaining: spade, diamond, club. If there's an ace of hearts on the board and a king of clubs on the board, then there can only be ace-king of spades and ace-king of diamonds. I can't remember the other 2 suits I said, but if there's 2 different suits accounted for, then there's 2 remaining. If there's only 1 suit accounted for, then there's 3 remaining. No real trick to it. I think it's basically common sense. Oops. Now the number of offsuit combos is even more annoying because you can't really calculate it without just listing out all of the different possible suits. So first we do our number of total unpaired combinations. So take ace-king suited for ace-king offsuit for example. We know there are 16 ace-kings, assuming no cards exposed, and we know there are 4 suited ace-king. So 16 minus 4 is 12. There are 12 ways of making ace-king offsuit. So I'll give you some quick examples, just because I just very quickly went through this. So we have ace of spades, king of hearts. How many combinations of aces are there? How many combinations of ace-queen? How many combinations of ace-queen suited? and how many combinations of ace queen offsuit. If you'd like to pause the video and run through this or calculate this quickly, you can feel free. Otherwise, I will count to 3 and give you the answers. 1, 2, 3. So for aces, we follow our rule of 6-3-1. There's one ace exposed, so there are 3 ways to make aces. For ace queen, as we said before, 3 aces, 4 queens. 3 times 4 is 12. For ace queen suited, there can't be ace queen of spades, but there can be the other 3. And then for ace queen offsuit, we subtract. 12 minus 3 is the 9. Example number 2. Hero has pocket aces, black aces. Flop is king of spades, queen of hearts, jack of clubs. And this example will lead into back into open office, so this will be the last one. So how many straights are there only making suited cards? Because in this particular example, we don't think our opponent can have the offsuit cards. There are 3 ace-10 suiteds, just no spades, and there are all 4 10-9 suiteds because there's nothing exposed. How many sets are there? We follow our rule of 6-3-1. There's 1 of each exposed. 3, 6, 9. 3, 3, 3 is 9. And how many suited 2 pairs are there? This one may be a little bit tricky, so you can pause if you want to work this one out. I'll give you a few seconds. So for each, there are 2 suits exposed. Take king queen suited, for example. The spade and the heart are exposed, so that only leaves clubs and diamonds. For king and the jack, the 2 black cards are exposed, so there can only be king jack of diamonds, king jack of hearts. And for queen jack, the hearts and the clubs are exposed, so there can only be queen jack of spades and queen jack of diamonds. So there's 2 each for a total of 6. So here's a link to the workbook which you'll need, or which will be helpful for the rest of this video. So it's tinyurl.com/WB4AM3. So you can think of it as workbook for applied math 3 if you want to remember how to type it in. WB4AM3. So if you followed that link and you downloaded the sheet, you'll have a workbook, and I figured this is the best way so you don't have to follow along and fill out the whole spreadsheet. If you'd like, if you want the open office experience, you can make your own spreadsheet and just follow my guidelines roughly. But I think the easiest way is just to have this skeleton and we'll fill it out together. So we've already determined that these are the number of combinations for that range in the PowerPoint. Now for those of you who skipped over and didn't watch the basic combinatorics lesson, no problem at all. The scenario we were left with was that hero has black aces, the flop is king, queen, jack, rainbow. And now just to add a little bit of context to it, let's say our opponent calls our under the gun raise from the big blind. So that's why he has such a a tight range. We will say he won't have king, queen offsuit and things like that. So now what I want to know is what percent of his range is a straight, what percent of his range is a set, and what percent of his range is a 2 pair. So we take all these combinations and we sum them up. There are 22 possible combinations of these better hands that he can have, better than aces. Now, since this is 22 combinations is the entire range, each piece out of that 22 will be the percent of that range. I hope that is self-explanatory. Now, the little trick that I explained at the end of the last video was that we can add the dollar signs, and it will lock in this cell, and that's what we want because we want each of these combinations to be divided by the total range. And we can paste special our formula. In the past we were paste specialing our text, but now we want to do the formula. And what we can do, if we'd like, is double check just to make sure that these add up to 100%, and they do. It's good to have kind of that that fail-safe because sometimes when we work on these spreadsheets for an hour or so, we can make some careless mistakes. So it's always nice to catch them. So there's two ways that we can calculate the strength. We can either calculate the number of combinations divided by the total range. So let's say straights, ace 10 and 10 9, there's 7 combinations. For the sets, king, queen, jack, there's 9, like we said in the PowerPoint. And for 2 pair, there's the 6. And we can divide, again adding in our dollar signs. Paste special formula again to get the formula to copy down. Once again, when we put in the dollar signs, it locks in the 22. So we can say that roughly 32% of his range is a straight, 41% is a set, and 27% is 2 pair. The other way we can do it, and which will sort of show how this works, or prove that it does work, we can just add these up. So for a straight, it was 31.8. We just add these chunks together. 31.8. For a set, it was, I don't remember, but it will work out. And we sum these up just to make sure that it's 100%, and indeed it is. So that's easy enough, I hope. Basically, take a range and then split it up into segments. So the straight segment, the set segment, and the 2 pair segment. So that's sort of the first step to creating and breaking down ranges. Next, what we can do is say, all right, maybe some worse hands we'll put in money. We'll say, maybe this is like a tournament, and our opponent calls and check raises us all in, and we think that this is his range for check raising us all in. So now to figure out the number of combinations for ace king, I'll write it out for those of you who need work with figuring out the combinations. It actually may be helpful for you to try to fill this out yourself. But for ace king, there's 2 aces and 3 kings. For king 10 suited, there are 3 kings left, no 10s exposed. Same thing for king 9 suited. For ace queen, just like the ace king, there's 2 aces and 3 queens. For queen 10 suited, much like the king 10 suited. Same with the jack 10 suited. So now once again we sum up our whole range. 48 combinations. And once again we calculate the percent of the entire range that each hand is. Locking in this cell B43. Oops. Sorry, it wouldn't let me paste special for multiple different selections. So we'll paste special for this one. We'll paste special for this one. We can sum it up just to make sure it's up to 100. And it is. So now let's say we want to know what percent of his range is better, what percent of his range is worse. Whoops. So we sum up the combinations that are worse, these ace king, king 10, the 1 pair hands. And we can sum up the combinations that are better. We can divide by the total range, and it'll tell us how often we can expect to be ahead when we're check raised. And just to double check, we can sum up the percents like I did before. So it would turn out that about half of his range, slightly more, is a worse hand. So now what I'm going to do is I'm going to pull up this this Wikipedia page for Bayes' theorem. So, you probably have heard Bayes' theorem thrown around, and I mean, it's very important for poker and constructing ranges. It's basically, the whole underlying laws behind constructing these ranges. So I figured I would take this example and example that's provided in the Wikipedia page. And turn this into a poker example and show you how Bayes works with poker. So the bottom line for us is this doesn't really tell us anything. He's got worse hands this percent of the time, he's got better hands this percent of the time. We want to know the equities. So Bayes' theorem allows us to multiply each of these each of these percentage of the range times our equity, add them together, and actually get our equity. So this example here in Wikipedia. Suppose there's a school with 60% boys, 40% girls. 50% of the girls wear trousers, and 100% of the boys wear trousers. So what's the probability that a student wearing trousers is a girl? Now, we can turn this into a poker example, just so we don't not calculating trousers. Writing this example out, it's as simple as 40% of the school is boys, and there's a 100% chance they're wearing trousers. 40% of the girls, and there's 40% of the school is girls, and 50% chance that they're wearing trousers. So in a poker translation, we could say that we get all in, and we think that we're ahead of our opponent, currently ahead of our opponent 60% of the time, and we think we're currently behind our opponent 40% of the time. When we're ahead, we're going to win every time. We have a lock hand, because let's say our opponent is bluffing and has 0 equity. When we're behind, we have a 50% chance of catching up. And if it's asking what's the percent chance that someone wearing trousers is a girl, trousers is equity. So what is our opponent's equity is basically what it's asking. So 60% we're ahead, 40% our opponent's ahead. Our chance of staying ahead is 100%, so our equity when ahead is 100. Our equity behind is 50. And now Bayes' theorem lets us simply multiply and create basically a new effective range. And this is something that we're going to do all the time throughout the series, which is why I went through the extra steps of explaining showing what Bayes' theorem is and how it applies to poker, because it's so important for poker math. It is probably the #1 most important thing. So these new chunks, they don't tell us anything. The 60% times the 100%, the 40% times the 50%, they don't tell us anything. There are these new pieces of a new range. What we can do is we can add them up, and this gives us a new range. And our new equity is what percent of this entire range is this effective equity. And it's as simple as dividing, just as we did before. And we can lock it in just as we did before. So our total equity, given this scenario, is 75%. Even though we're ahead 60%, since when we're ahead, we're always staying ahead, and when we're behind, we're often catching up. The result is our equity is stronger than our percent chances of catching up. And for our opponent, it's the resulting 25%. So the chances that our opponent wins is 25%. So the chances that a person wearing trousers is a girl is here, this 25%. And you can go to this Wikipedia page if you're interested in reading out the rest of it, and it breaks it all down. 20 girls wearing trousers, so the 0.2 of girls of villain winning, and the 60 boys wearing trousers. The 60 that we're winning creates 80 total people wearing trousers, and yeah, hopefully that just gives you understanding of what we're doing here. And if we'd like, which I'm not going to do because we're going to have to do this in a few minutes, and hopefully it was a simple explanation of what this would do, which would be tedious, is we can add the equities. Let's say, against Ace King we're 90%. We would look it up in PokerStove. Against King 10 we're 60%. I'm just throwing out percentages there. Then what we would do is we would multiply, and we get our new effective ranges. our new effective equities, and figure out our resulting equity. So next, we're going to start with weights. And weights are very important, and weights are the type of thing that I think a lot of people resist on. So I'm going to go back to PowerPoint in 1 minute or less than a minute and explain my reasoning for weights. So I've thrown together some notes on why I think weighting is important and the sort of the pros and the cons of it. And the reason I've done this is because I've used these weights a lot in past videos and in past series, and I've gotten a lot of comments in the comment section about maybe my possible overuse of them, or why we shouldn't use them. So basically, there's two reasons why I think we need weights. The most likely scenario is we don't know how our opponent plays. We know that we know certain things about him. I mean, maybe we've even played with him a lot, but we don't know exactly how he plays. And as a result, there's a range of opponents, or the range of styles he may play. If we just are looking at pre-flop stats, then post-flop he can be anything from loose aggressive to really nitty. There's no way of knowing for sure. So we can only weight the likelihood of all these situations. It's unfair and untrue just to assume that he's playing, straightforward or playing, right in the middle. There has to be a chance that he'll fold a strong hand, and there has to be a chance that he'll call down with a weak hand, or that he'll bluff raise with a weak hand. So they may be, small weights, they may be unlikely, but they're possible. The other reason why we may use weights is because our opponent may mix up his play. Maybe our opponent decides to slow play some percentage of the time, or maybe he's on tilt, or he may say fast play a set 25% of the time, and that's just his style. Some people do that. So if that's the case, then that's a use of weights. Now that's less likely. The number one reason I use weights, and I think they're critical, is because we have to deal with the range of all possible opponents. So let's take a 20/16 over 100 hands. We don't have any read. We just see pre-flop stats. Maybe we've seen that he c-bet like 3 out of 4. I mean, things that just don't really tell us much. We don't know if he 3-bets suited connectors pre-flop, or if he 3-bets ace-10 offsuit pre-flop. We don't know how often he slow plays or fast plays his strong hands. We don't know how often he floats or bluff raises. We don't know how lightly he calls down, or how nitty he is against multiple barrels. We don't know how thinly he value bets, and we don't know how he mixes up his play. So there's so many unknowns, and we have to account for all of these. We may say that this player might slow play 25% and fast play 75%. It may not be accurate. It may not be exactly accurate that our opponent will slow play 25%, but it is more accurate than assuming that our opponent will slow play 0% and fast play 100%. We have to take into account that there's a chance that happens. If we don't, then our numbers get all skewed. Now, as I said, I've gotten some comments about maybe overweighting. So the pros of not weighting are that it saves time, and that's a big one, because I mean, when I was making those Professor Plotkin videos, I can't even tell you how much time I was spending just entering in little weights for each street, and changing around the combinations and coming up with these new ranges. And the thing is, when you make all of these assumptions, in the end, maybe you're even worse off than where you started. So that's sort of the risk of weighting too much. So we want to take things into account, but we won't necessarily want to weight every single last possibility. The cons of not weighting is, like I said before, there's few absolutes. We can't say it's 0% or 100%. That's so rare that, I mean, the chances that a tag regular raises pocket aces on the button, that's 100%. There are a few things that, I mean, we can even maybe round up to 100%. The chances that our opponent, bets the nuts on the flop as a continuation bet. It's likely, but maybe there's a 5% chance that he'll slow play, even though regulars don't often do that. So I mean, those are the types of things that we do need to or I do believe that we need to account for, because it can make a big difference. Pre-flop, and this is kind of a big one, and this is often when weights are the most useful and sort of the most tedious as well, is when you're looking at a pre-flop 3-betting range. I mean, who says your opponent is more likely to 3-bet as a bluff with Jack Deuce suited, or 5 Deuce suited, or 7-4 suited? I mean, all those will probably be roughly the same. So when the flop comes Jack 3-3, we can't just say he never has a 3, because there's a chance that he bluffed with 7-3 suited or 9-3 offsuit. I mean, even if it's a small chance, if there's 1% chance that he 3-bets 3-2 suited, 4-3 suited, 5-3 suited, 6-3 suited, 7-3 suited, there's a 1% chance for each, well, that'll add up, and that'll be a considerable portion of his range that may have our ace-jack in just horrible shape. So we can't just assume that it's all or nothing. And like I said, those small percentages can make big difference when we're talking about nearly 100% equity. 1% of a range, if yeah, I hopefully that rant got my point across for why I believe that we do need to wait. But what I'm going to try to do for this series is I'm going to do two things. One, I'm going to try not to overweight, and two, I'm going to start testing. Do I have another? Yes, I do. So my goal is that we're going to blend these approaches. I'm going to really try not to just wait too much. And if you guys catch me, being too specific with these things and it's taking up too much time, then please comment on that in the comment section. And also, I'll try to round. I'll try to maybe do something like 0%, 50%, 100%, and we'll see. We'll see how our specific versus our estimated ranges work out, and that's something I've never done before until this video. So hopefully we'll get an idea. Maybe this 0%, 50%, 100% estimate is nearly the same as the really specific one in most instances, and if that's the case, then we can just go with that. Here we are back in OpenOffice, and now you should have an understanding of how to construct a basic range. You should have an understanding of how Bayes dictates creating new ranges based on weights and equities. And you should have an understanding of why I believe that weights are critical. And from that, we will now add in the possibility that, well, our opponent may 3-bet some of these hands sometimes. He may fold some of these hands sometimes. We don't really know much about our opponent, so we can't assume that he's always going to call ace-king. Or we can't assume that he's always going to call king-10 suited. Or never will call king-10 suited. So I added in these weights, and I did them pretty quickly because this example is just to show how to construct a new range. Please don't focus too much on the weights, because for some of them I just very quickly put in a number because it's not that important for this one. It'll be more important for the next example because that's going to be a hand that we're going to, or a situation that we're going to develop, and we're going to calculate EVs and things like that. So the weights will be important. For here, not important. So now we basically do what we did here. We have our combinations, we have our weights, and we're going to come up with a new range based on the effective combinations. So we can multiply combos times the percent, the weight percent. Oops. And we can copy and paste special for formula. And again, we can copy and paste special for formula. And now what we want to do is we want to sum up to come up with the entirety of this new range of effective combinations. Whoops. And we're going to sum all of these effective combinations, and as a result we get 21.65 effective combinations, which is our new range. So what we can actually do is divide our effective combinations by our original combinations, and we could say that of all of these hands, he's calling 41% of the time. The other 53% he's either 3-betting or folding. If we were really interested in the exact weights, we can do a 3-bet weight, a fold weight, and a call weight, and we can actually see what percent he's 3-betting of these hands, and so on. So now we have our effective combinations, we have our total range of effective combinations, and then it's exactly what we did here up above, where we divided the combinations divided by the total combinations, and we'll divide our effective combinations by our total combinations. So this one divided by our sum, and we'll lock it in with the dollar signs. And we can do our copy, Control C, and then paste special. And now we can add up our total combinations of worse hands. We can add up our total combinations of better hands. And then we can divide into our total range. And we see that given these weights, 52% of the range is worse. Now, one other thing we can do is, like I was saying before, I want to know how well this estimate or this estimating strategy or approach works. So what we're going to try for this video, for this example, and then an example toward the end of the video, will be anything between 33 and 67 will count as 50. Anything above 67 will count as 100. Anything below 33 will count as 0. So we'll round it into thirds. So the 50 will stay at 50. 25 is below 33, so we'll turn that into 0. 75 is over 67, so we'll turn that into 100. 0, 100. Stays at 50, stays at 50. 0, 0, 100, 100. Stays at 50, stays at 50. So we went from 52.48 to 53.47. So roughly the same if we want to know our quote unquote margin of error or margin of error when using this method compared to the other one. We can say that this 53 minus our 52 from before is 52% divided by our total 52% from before. So we're off only by 2.5%, 2.6% relative to our estimate before. So so far so good as far as going with this method of just going with 0, 50, or 100. And if if we started from scratch, then that's what we would do. We would either do 0, 50, or 100 rather than listing them all out and then estimating. So just to make it a little cleaner, I'll be right back in PowerPoint and I'll explain our hand example that we'll be working on for the rest of this video and also for next video. So now at last we have our real poker example, and we're already about 2/3 into this video, so we're going to get as far as we can and continue with it next video and potentially the one after, but hopefully we'll get it all wrapped up with our different what-if scenarios and a combination of ranges with EV tables and coming up with some strategies next video. So for our example, we've got 100 big blind effective stack. Ignore the rake for now. In the future, I'm going to introduce the rake because it's very important. It can have a surprisingly big impact, especially on some of the more marginal situations, obviously. So both players are regulars. We don't really know anything specific about them. They could be loose or tight. They can be aggressive or passive. So once again, we're going to need those weights. We're going to need to come up with the range of all regulars that could fit under this description that we have of them, which are just regulars. So our villain opens from the hijack for 3.5 big blinds. The small blind calls. We don't really need to worry about the small blind right now. Maybe we'll take a look at what happens in a three-way flop. Check raising like 2 players, but for now it's just going to be 1. So we call in the big blind with King Jack of clubs. The pot is 10.5 big blinds. The effective stack is 96.5 big blinds. and the flop is queen, 9, deuce, rainbow, and we've got a gutter, overcard, and no backdoor flush draw. And first we're going to have to come up with a range for the hijack, because first we need to know, this is a little spoiler, he's going to continuation bet, and then we're going to think about check raising. And we're going to first need to know his opening range, then we're going to need to know his continuation betting range, then we're going to need to know how he responds to a check raise. So first we will go into our open office and come up with a hijack range. So in the interest of saving time, I've already filled out this pre-flop hands table, but I'll explain my method for doing it, because there's a couple of ways you can do it. So we have this queen, 9, deuce flop, and you could start with the nuts and move on down. You could start with pocket queens, pocket nines, pocket deuces, queen 9 if possible, queen deuce, 9 deuce if possible, down to pocket aces, pocket kings, ace queen, and so on, and you can work your way down. And that's good if you're starting with post flop, if you're just listing out all the possible hands you can have post flop. But since this hand starts pre-flop, we want to start with the pre-flop hands without confusing ourselves. And in order to do it without confusing ourselves, we should be consistent with how we list out our hands. So for these videos, we're going to go with the method of starting with pocket pairs, going to ace x, king x, queen x on down. It's less confusing than going with like grouping suited connectors, grouping broadways. So that's what we're going to do. In the process of doing this, it's highly advisable that you group hands that are similar in terms of hand strength, at least at the current moment. So on this queen, 9, deuce flop, for all intents and purposes, aces and kings, they're basically the same hand. They're going to respond to a check raise in likely a very similar way. If you really strongly feel that maybe aces are more likely to slow play for whatever reason, then you could split them up. I don't believe that's to be the case, and as a result, I'm going to bunch them together. I'm going to write out this queen, 9, deuce just so we have something to look at as I explain this. So queens, 9s, and deuces, these are the sets. Again, they're going to probably respond in the same manner. As a result, we can group them together. If you have any particular reason why you think a set of queens may be more likely to slow play than pocket deuces, then that would be cause for splitting them up. I don't believe that to be the case. And especially I think it may be just be going overboard in terms of waiting to be splitting those up, because in reality it may be true, maybe slightly true that someone would be more likely to say slow play a set of queens because with 3 queens accounted for, they may be more likely to be facing a bluff. Next, moving down in the pocket pairs are pocket jacks and pocket tens. Again, effectively the same hand, and then the pocket pairs between the 9 and the 2. Effectively the same. So now we've covered all the pocket pairs: aces, kings, queens, jacks, tens, nines, 8s down through 3s, and deuces. Now we go for our ace x hands. We could have bunched ace king with ace jack and ace 10, but I think they're slightly different. The ace king may be more likely to float a check raise, so having the 2 overcards, I decided to keep that separate. Ace queen, top pair, top kicker, obviously as far as aces go, in a class of its own. Then again, we could have decided that ace jack, ace 10, ace 8, ace, and down are similar hands. But for this, I split them up. Maybe the ace jack through ace 10 would be slightly more likely to float a check raise, maybe more likely to check through the flop, or maybe some players would be more likely to bet the flop. So I kept those on their own. And then let's say as far as the rest of the ace x, he's not opening them offsuit. He'll open ace 10 offsuit, but he won't open ace 9 offsuit. But he will open all suited aces under my model. So we included those. Onto king x, we'll first, top pair, strong kicker, gut shots, second pair, a couple of other top pairs. Yes, we could have grouped them together. Open ender, second pairs, and so on. and this is his range, and we can go into Poker Stove if we'd like, and we can see, you know, what that range would look like. So it's all pairs, it's all suited aces, it's offsuit aces down to ace 10, it's suited kings down to king 9. Oops. It's we have a king jack offsuit in here. Then queen jack suited, queen 10 suited, no queen jack offsuit for this range. Jack 10 suited, 10 9 suited, jack 9 suited, 10 8 suited, 9 8 suited, 8 7 suited, 7 6 suited. Everyone's range will probably be different, you know, for creating them. You know, maybe some of you decided to add in a queen jack. I opted not to. You know, he's got 2 regulars in the blinds. Should probably not be raising queen jack offsuit. So, you know, this is a spot where you can opt to wait. Maybe you could say that he'll raise queen jack offsuit 50% of the time, but maybe for the sake of not overweighting, I left it out. But if you feel that that's necessary, that's, again, you know, to each his own or her own. Now the next thing we have to do, excuse me, is list out the number of combinations given the flop, given our hand, which is king of clubs, jack of clubs, and then the flop was queen of hearts, diamonds, spades, hearts, diamonds, spades. And, you know, I have them all, you know, listed out in front of me, but I figure, you know, for the practice for everyone, we'll go through it. So there are 6 aces, our 6 3 1, and 3 kings. For sets, there's going to be, you know, 3 of each. Again, our, you know, our 6 3 1 combinations for pocket pairs. Jacks and tens is going to be the same as aces and kings, where there are 3 jacks and 6 tens. 8s through 3s, we can just count on our fingers. 3, 4, 5, 6, 7, 8. So there's 6 ranks. There's no blockers, so they're each going to be the full 6 combinations. For ace king, we got 4 times 3 is 12. For ace queen, we've got, again, 4 times 3 is 12. For ace jack and ace 10, for the ace jack, we've got the 12. For ace 10, we've got the full 16 for a total of 28. Ace 9 suited, only the 9 is accounted for. Ace 8 through ace 3, there's no cards accounted for. So again, it's 6, you know, 3, 4, 5, 6, 7, 8 times the 4 is 24. It's good to sometimes, you know, list out the computation, because, you know, when you're doing so many of them, it's possible to make a mistake here and there, an adding mistake when you're rushing. There's only the deuce accounted for, that's 3. Here's 3 times 3 is 9. For king jack, they're going to be 9 because we've got a king and a jack accounted for, and for king 10 suited, only the king is accounted for, so that's going to leave 3 for a total of 12. For king 9 suited, there's both a king and a 9 accounted for. 9 of diamonds, king of clubs. As a result, that only leaves spades and hearts. So there's only 2. Queen jack suited, same deal, 2. Queen 10 suited, got the 3 because there's no 10 accounted for. Jack 10 suited, we have a jack. Jack 9 suited, we've got just the 2 because the club and the diamond are accounted for, leaving spades and hearts. 10 9 for 3, 10 8 for 4. 9 8 suited for 3, 8 7 suited for 4, 7 6 suited for 4. I'm going to quickly double check with my sheet just to make sure it matches up to avoid any careless mistakes, and it does. So the next thing that I like to do is I like to categorize the hands. It makes it a little bit easier to make sure that you're consistent. So we're going to categorize and then we're going to sort. So we can just, you know, in different situations, we may break it up in different ways. We may break it up by draws and made hands. We may break it up by hands likely to stack off versus hands unlikely to stack off. We'll get into that later in the series. For now, we'll keep it simple. Strong, medium, weak. Aces and kings on this flop, that's a strong hand. Sets, the best 3 hands, obviously strong. Underpair, we'll call medium. It's not quite weak. These pocket pairs are definitely weak. We'll call ace-king medium because, well, it's definitely on the borderline of medium and weak, but, you know, it's the type of hand he could flow with. It's maybe roughly equivalent to having like a king jack or a king 10 type hand. Maybe a little bit worse because there's no outs to the nuts, but it also has a little bit more showdown value. It beats all draws, so we can call that medium, I think. Top pair, top kicker is kind of on the borderline of strong and medium, but still pretty strong on this board. Ace highs here, they're weak. Just with ace king on the borderline of medium and weak, these are clearly weak. Second pair top kicker is medium. Ace high weak. Bottom pair we'll call medium for the same reasons as ace king. It's got some showdown value against, it beats draws, and it's got some outs to a relatively strong hand in the form of a deuce and an ace for two pair or trips. Top pair top kicker. Top pair second kicker is we'll call a medium hand. Gutters we'll call medium. This king 9 we'll call medium. We'll call these medium. Top pair, open ender. Second pair. Gutter. This is sort of on the cusp of medium and weak, but the fact that we could be check raising king jack, which we are. Actually, no, they don't share outs. It's still, if we could be check raising king 10, then the 10-8 would be no good. We're just estimating. The second pair we'll call medium, and these are clearly weak, just air. And it can't hurt to list out just that these are all 100%. Sorry. So what I'm doing is just dragging down. You have to highlight 2, otherwise it counts up. So these will all be 100%. So that's our weight. We're saying that his range is static, or not static. His range is what it is. There's no weights. We're not going to add in like a 50% for queen jack offsuit. In the interest of not overweighting. So now what we're going to do is we're going to sort. I would like to sort by hand strength, and the reason for that is because it makes it easier in saying or determining how our opponent will respond, with strong hands, medium hands, weak hands, and without having to go strong, medium, weak, medium, strong, weak. They'll all be similar. So with weak hands we can all give a given percent. With strong hands we can all give roughly similar percent. So this is something I believe I have not showed yet in open office. And actually, this brings me to something else, something that drove me crazy that I had to change. When you're writing out a hand like say Queen Jack suited, what it does is it tries to autocorrect it. It thinks you're making a typo, like if I was writing too quickly and I wrote like my name like that, it wants to autocorrect it. I had to change a setting, so I'm going to teach you that because that was just driving me absolutely insane. I had to Google it. If you go to Tools, Autocorrect, maybe I did that too quickly. Tools, Autocorrect options, and correct 2 initial capitals like this. Uncheck that. I think the default is checked. Capitalize first letter of every sentence. I unchecked that as well. So the next thing, that I wanted to show was how to sort. So in order to sort, first we can either highlight the whole rows, or we can just highlight the boxes. Then go to Data, Sort, and we can pick a column to sort by. I'd like to sort by C, and we want it to go strong, medium, weak. So that's not in any like alphabetical order or anything. So we're just gonna have to do it manually. But as long as it puts them together, that's good. So what's nice about Excel is you can cut and insert. I don't think you could do that in this. So we want to take these 3 strong ones and we want to put them up here. Don't worry about that. So we'll copy and paste the strong ones in, but now we have to delete the strong ones back out. So we plug those in there, and now we've got them all sorted out by strong, medium, weak, and then sorted by, within those groups, it's sorted by the pre-flop hands, starting with pocket pairs down to ace x, down to king x. So now we've got our nice table in rough order of strength. So now we can continue on with our example. On the flop, small blind checks, we check. The pre-flop raiser, who was last to act, bets 8 big blinds. So now we want to create his continuation betting range. And in order to do that, we can add a cbet. Oops, let's copy and paste actually to get the format. Just Control C, Control V. And we'll make a cbet range. And let's steal the format. So you can go just like this. Copy, Control C, right click, paste special, and we'll steal the format. And that way we get the percents and we get the borders. So that's nice. And we've already done the combinations on the flop, which is nice. There's no need to do a pre-flop because we already knew what the flop was. So we don't have to edit it. It becomes a bit of a pain. We'll take a look at, when the turn's a 10, we make our straight. We're going to have to adjust some of these. Now, pocket 10s became a set. There's down to 3 combinations. So we'll have to, tweak for that. King 10, picked a pair, and, Jack 10 picked a pair, and so on. So what we need to do is we need to have continuation betting weights. And again, I'm going to try to not be so specific because, I said before, there's always a chance that there's very few truisms in poker. Like, we don't know for a fact that this guy is going to, or this girl is going to bet aces or kings 100% of the time, but for all intents and purposes, close enough. If we make it 99% or 98%, it probably won't make much of a difference anyway. For sets, well, I think sets people do slow play from time to time, so we'll say 95%. I think that's reasonable. Ace Queen, basically the same thing as for a set. I mean, for aces or kings. Now Jacks and 10s, that's an interesting case. Well, when he bets, for the most part, only better hands are calling, worse hands are folding. So maybe he wants to protect his hand, maybe he wants to bet in position. So maybe he'll bet 50% of the time. That's a style thing. I think I personally probably check there very often. Ace King, I think that's a pretty good bluffing hand, so we'll say 75%. Ace 9 suited can check for a lot of the same reasons as Jacks and 10s, and that's why it's kind of nice to keep these categorized by strength, because you'll make sure that you're consistent. Because if they were in completely different areas of the table, then we maybe say Jacks and 10s 50% and Ace 9 suited 40%. That's just not consistent. They should be roughly the same. They're very similar hands. They have slight differences, but I won't get into that. Ace 2 suited, well, that's very similar to Ace King, as we said before. The King Queen, I think, should roughly be the same as the Ace Queen and the Ace Queen, the Aces, and the Kings. So let's actually say 100%. Yeah, we can do that. King Jack and King 10 suited. Gut shots, I think those are the types of hands that will bet very, very frequently. They could check because they have outs to the nuts, but let's say 90% of the time. Hopefully we're not getting too specific with these weights. King 9 suited, roughly the same as the Ace 9 suited. Queen Jack suited, a little weaker than the King Queen. So instead of 100, let's say 80. The Queen 10 suited, should be the same as the Queen Jack suited. The Jack 10 suited, similar to the King Jack and the King 10. If he decides to check a draw to the nuts, doesn't want to get check raised, maybe wants to play a little deceptively, then maybe he'll check. So let's actually say 95. I think vast majority of people will follow through with the open-ended straight draw. The Jack 9 suited, 10-9 suited, 9-8 suited. And honestly, I probably could have bunched these together, and I should have for the pre-flop. But anyway. We'll say that these hands are a bit weaker than the King 9 suited. Now we're starting to get into hands maybe that may be more likely to check. So we'll just say a little bit less likely to bet, 40%. And then the 8s and the 3s. These are really pretty weak hands, and they do have a bit of showdown value. They have no equity when called by a better hand, and when they're ahead, they're just going to get bluffed out. So we'll make that pretty low, 10%. Ace Jack, Ace 10 has a bit more equity. Say 75% of the time. I think that's the type of hands that people often bet. The Ace 8 through Ace 3 suited, this is a bit weaker, but similar to the ace jack, ace 10. 10 8 suited is, he's got a gutter. It's probably enough to go on to continuation bet. And we'll say these complete air, bottom of his range. Maybe some people see bet too much, so we'll say 10% of the time, but really these hands shouldn't be betting. And now what we've done is we've created these continuation bet weights, and now what we want to make our effective combinations. So let's copy paste this again just to keep the format. Effective combos. And I like formatting, so we'll highlight them all and we'll get this nice grid going just to continue with the border in case we want to print it out. And now once again, very similar as before, except at each decision point we can keep multiplying. If we had 5 different decision points, we would just multiply one by the other, by the other, by the other, and we create a new range from it. So, oops, my button sticks. Number of combinations. It's usually a good idea to start with that. Times preflop raise percent times continuation bet percent. And that's going to be our number of effective combinations, and we'll get a 1 decimal place. Let's copy. Let's paste special formula. And format, actually. And that way we'll keep this 1 decimal place. Very nice. Let's sum it up. Now we've got 118 effective combinations. Let's copy paste again to keep the format. And we'll go percent of range. And again, let's keep it with our border. And now, like we've done so many times throughout this video, effective combinations divided by the entire range. Lock it in with the dollar signs. Let's format it nicely with the percent. 1 decimal place. No need for 2. And we'll paste special both the formulas and the formats. And there we go. This is our new range. And now let's say we want to categorize it by strong, medium, weak, just to get an idea of what his continuation betting range looks like. And this is the type of thing where in Professor Plaque, and I would go and put it in a bar graph. It's kind of nice to see this visual of what this continuation betting range looks like. So we'll go strong, medium, weak. We'll go strength. We'll go percent of range. We won't bother with the combinations because we can just add up the percents. We'll get our nice formatting going, put a grid box around it. Put our 20% gray coloring on the top, and we can just start adding them up. Summing, actually, which is also a nice thing about sorting, because now we can just sum instead of having to find all the individual ones. Which also leads to many mistakes when you have to click, 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 click when they're all scattered around. And now 2 things that I actually forgot to do, which we really should do, is sum up, just to make sure we got 100% for both, avoid any mistakes before they get worse. So there we go. Now 25% of his range can be categorized as strong hands, 40% of his range can be categorized as medium hands, 34% can be categorized as weak hands. So now we're back at our PowerPoint. We know that our opponent bet 8 big blinds, and we go ahead and we check raise to 28 big blinds, about 3.5 times his bet size. Now, what we're looking for here is basically 2 things. We're looking for our fold equity. If the fold equity is significant, then then we can just stop right there. We don't need to know about our implied odds. We don't need to know about our chance, or need to bluff the turn and things like that. If the fold equity isn't sufficient, then we really need to know his call range. We need to know what type of range we're going to be against on the turn, so we can figure out first our implied odds on hitting a straight, maybe any value on hitting a king, and then any chances we have of bluffing. If we know the fold and the call, then we're going to know the 3 bets. So as a result, we're going to end up with all 3 ranges: a 3-bet range, a call range, and a fold range. And what I've added here is a I could just copy the format over, and we'll start with the check raise range. I'm sorry, we'll start with a 3-bet versus check raise range. Sorry about that. And we'll add our format in. Now this is where some small percents can really matter, where we may need to get to these small ones, because these small percents, because maybe occasionally he'll throw in a bluff raise, and that's going to cost us in terms of fold equity. So we can add in some small ones, but we'll get there. Being that it's a dry flop, I really think it's unlikely that he's going to 3-bet aces and kings. For the most part, when we check raise, he 3-bets, we get stacks in. He's going to be in bad shape. So I think it makes more sense to call against bluffs, and I think as a result, most people are going to, I'll even say 20%, or most people are going to not 3-bet. People do tend to fast play sets sometimes, so let's say 40% of the time he'll slow play, 40% of the time he'll call. With ace queen, I think that's even less likely that he will he'll 3-bet. Aces, jacks and tens, that's just so bad. I think it's just really just not likely. He even has those hands even have blockers to some of the draws. So to me, that just doesn't make a lot of sense. Ace king, we'll say some of the better hands can bluff 2% of the time. Some of the better bluffing hands, he does beat draws in this case, so and maybe he'll stick it in 2% of the time. Ace 9, I think a lot for the same reasons as jacks and tens, going to be 0%. Ace deuce suited, I've been treating for the most part as ace king so far, so we'll leave that 2%. King queen, I think, is in the same neighborhood as the jacks and tens. Just pretty unlikely that he 3-bets that. The draws, that's possible. With the king 9, we're gonna, let's say 0. These top pairs 0. Jack 10 is really the only strong draw, so being that a lot of money's already in the pot, it's an inflated pot pre-flop. There's only about one pot size bet left. It's possible. Maybe we would say 25%. He'll 3-bet the Jack 10 suited. Then when we get down to like the Jack 9 suited, maybe those hands are so weak for calling a 3-bet they decide to just stick them in. So let's say 1%, 1%. These hands are just really pretty bad. Let's say the ace high is 1%. At least they have some outs when they're behind like a top pair hand. I don't know, these, it's hard to say with these 1%. It's just in there to add the possibility, because we're dealing with such small percents anyway that even 1% can make a difference. Now these basically air hands, we're gonna, whoops, sorry, 0%, 0%. And let's get rid of these decimal places, XX. So now we've got a 3-bet range. Let's before we calculate what this range looks like, let's move on. We're in I, let's go to L. We're going to copy, and we're just going to paste in the formats. Paste special, just the formats, just so we have the percents and the no decimals and all of that. We'll make this fold to check raise. Depending on the example, depending on, I guess, even my mood, I may go with call next and then have fold be the resulting one. If you're picking two, the third one is coming anyway, so it should all be the same regardless. But folding is sometimes pretty easy, because now we know that he's not folding over pairs. We know he's not folding sets. We could say he's not folding top pair, top kicker to a check raise. He'd have. I don't even think it's worth giving 1%. The jacks and tens, I think that's very possible. It is a big check raise. There's only that one pot size bet behind, so it's hard for him to really use his position. So let's say he folds 60% of the time with the jacks and tens. Maybe that's a bit on the tight side, but check raises are strong. He did continuation bet 3 ways. He did open from the hijack, so I think we are representing a good amount of strength. So we can get him to fold 60% of the time. Ace king, let's say he folds 85% of the time, roughly. I'm trying to look at my sheet here. The ace 9 suited, let's tag to the to the jacks and tens, basically very similar hand. The ace deuce suited, I've been treating very similarly to the ace king. The king queen, maybe occasionally we get them to fold. The gutters, I'd say they're going to fold more often than not. Let's say they're similar to the jacks and the tens. If it's basically 40% of the time he gives us credit, and 60% of the time 60% of the time he gives us credit. Excuse me. In this situation, and then the rest he either calls or check or three bets. With the king nine suited, we can say that's very similar to the ace nine suited. And the queen jack, queen 10, very similar to the king queen. So we'll say 10%. The queen will go in incrementally higher. Sorry, I keep changing my minds. I have some numbers written down, but I always change my minds when I go over these. It's such an inexact science. So maybe he's a little more likely to fold queen jack than king queen. He's a little more likely to fold queen 10 than queen jack. Maybe occasionally he's a nit and he folds jack 10. There is not a lot of maneuverability there, so it wouldn't be totally surprising if he folded. Maybe not even that nitty. Jack 9, I just actually convinced myself that he'll fold jack 10 maybe more often than we realize, because it maybe not that bad even. The jack 9 suited, probably more likely a good bit more likely to fold than the king 9 suited, and these hands are all effectively the same. This hand, I'm going to say he just folds 100% of the time. I'm going to say he doesn't float any of these hands. Now once again, we got to go to our fold. So you're going skip, skip, fold, skip M, skip N, and now let's go paste special our formats again. And this is going to be call, check raise. And now what's nice is now that we've got two, obviously these all have to equal to 100. So 1 minus this, and we can just copy it on down. Sorry, I just poked my headset. So now we have our weights. They all equal to 100. And we're going to start coming up with our effective combinations. We'll copy the formats, paste special, format, paste special, format, paste special, format. And we can even paste those. So now as we know, we need to multiply. We could take these past effective combos and multiply again by our new weights. I prefer starting from scratch just to make sure we don't have any errors, or if we do have an error, it doesn't get carried over. So each time we're just going to multiply. Flop combinations times the pre-flop raising percent times the continuation betting percent times the 3-bet over our check raise percent, and that gives us our new effective combinations. Now what we can also do, so we can copy these over from J to M to P, we know we want this to be free. And this is what I would explain toward the end of the last video, is with adding in the dollar signs. We know we want this, we know we want the green to be free, because when we drag this down, we want it to carry down for these weights. When we copy it over, we want it to carry for these weights as well. This is not necessary, but I want to teach you the right and faster way to do these things. So what we want to lock in is we want to lock in these columns. We want the combinations column to stay the same. We want the raise preflop combination column to stay the same. And we want the continuation betting column to stay the same. So we lock in. We put a dollar sign in front of each of the letters, in front of the B, the D, and the E. And what that's going to do is let us very simply copy down, copy, paste, copy, paste. So quick and easy, and it worked. B times D times E times Q times O. And one more thing is the reason why we're continually adding in these raises preflop is, let's say we ultimately decide that he's not raising 8-7 or 7-6. Then we can so quickly just change that, and it'll change all of our subsequent numbers. This table changed, these tables changed, so it's pretty nice. We actually going to need one more column. Let's insert a column to the right of each one. I didn't account for that. And first we need to sum all of our effective combinations for each one. And these should all add up. Our old effective combinations and all of our ranges. So we can add that just to be safe. This one plus this one plus this one should all equal 118.05, and they do. So we made sure that worked, and they all equal to 100. So that's good. So before we continue, what we can actually do is we can categorize our ranges by action and by percentage of the range. So he's either going to 3-bet, he's going to fold, he's going to call. And let's format it. Let's put our borders. Sorry, misclicked. Let's put our borders. And let's put our highlight, gray 20%. Let's bold it as we did over here, just to be consistent. And now since we know these all add up to this total number of effective combinations, we can divide each one. And this will tell us how often he makes each action, given our weights. And also the very nice thing is that we can change around our weights. We can say, and I think we should do that next video, is we can say, what if he's a nit? What if he's a really loose aggressive player? And we can see how our EV changes, and all of the subsequent numbers will change as a result, which is really the nice, that's the number one benefit of using Excel or OpenOffice Calc. So we see that he's folding 55%, he's 3-betting 7%, he's calling 38%. Now we should go in and come up with percentage of new range. And we can copy it for each of these. So we divide now by our, we want to keep this one free again, very similar to the thing we did last time. We keep this one free, and now we want to lock this in by number, not by column, because when we copy over to here, we want it to be a different column, but when we copy it down, we want it to stay the same row. So we want it to stay 127, so we lock in the 127. Again, you don't have to do that, but it's a good habit to get into. So now we see that the aces and kings are 21% of his 3-bet range. Oops, sorry. We can drag them on down. Don't double click like I did. So we can now, since I locked it in, we can copy paste, and as you can see, since we only locked in the number, it just locks it in by row, but moves around the column. So now we have our new ranges. What we can do is now we can calculate, and keep in mind before we continue, if we want to calculate EV, we're finding the EV of a check raise, right? That is, we want to find out if that's the best play. The alternatives are we can fold or we can call. We don't know the EV of a call. It very well might be profitable. Given experience, I think it's likely to be marginal, like at best. So, we don't have any backdoor draws. We're calling with king high. I don't really have much showdown value. He continuation bet 3 ways. So more likely than not, it's at best very, very marginal. So we're going to say that we know the EV of folding is 0, and let's say the EV of calling is also roughly 0. So in order for check raising to be the best play, it simply needs to have an EV of greater than 0. So we'll continue with, we'll keep that in mind going forward. Now, I promised myself I wouldn't make these videos overly long. I think people get intimidated when they just look and they see it's over an hour, which this is likely going to be, and Hopefully it's not too tedious, but which is why I try to break it up. But it may be. So we're going to stop after this next. We're just going to figure out our EV based on this fold equity, and then we'll call it a video, and then we'll definitely continue with this and get to some more interesting applications. I think this was these first three videos maybe weren't eye-opening, but I just think these tools are essential in order to get to the real tough examples that we can really learn a lot from. So hopefully you've bared with me to this point, and you will continue to do so, because I think we'll start to reap the rewards starting next week, or reap the rewards especially because I've learned a lot so far, but I think we'll learn even more, or we'll learn at an even more accelerated rate. So let's with all that ranting out of the way, we'll go forward. So let's make our EV table. So EV of check raise, given that we have no future equity. So now basically what this tells us is, if this is profitable, if check raising in a vacuum is profitable, assuming that we just lose every time we get called, then we probably don't need to go much further. And we can stop there, and we know it's profitable. We don't need to know how much value is added from check raising, because we know it's already profitable. We know this is super profitable, and so yeah, we'll start with our EV table. We'll go with result, percentage of the event, our final stack, and our average final stack, and we'll go with our starting stack up here, and we'll go with our formats with our 20% gray, our borders. We know our starting stack based on our PowerPoint is 96.5 big blinds from the point that he bets. The possible results are he folds, or he calls, and we lose. Now we know that he folds 55% of the time, and as a result, we know that the inverse, he either calls or 3-bets and we lose. And these should add up to 100, which they clearly do. Next, for our final stack, when he folds, we get the 10.5 that started with, and started in the pot, and his 8 big blind bet. So 18.5 on top of our starting stack. If we lose, then we risk 28. We've lost that 28. So we simply multiply as usual. Add them up. This is our average final stack. And our EV is the difference, is we're losing to 2.45 big blinds. Or actually, let's keep it consistent, 2.4 big blinds. So what this tells us is simply that we need to start looking into first of all, or looking into 3 things. First, the value of hitting a 10. Secondly, the value of hitting a king. And thirdly, the value of future bluffs, barreling. And that'll be our our 2-street scenario, and we'll get into that next week. The quiz for today is going to be, I would like you to take this table and I would like you to round it, to take a look at our resulting results based on estimates for our weights and find the margin of error, new EV, which is new EV minus old EV divided by old EV. Basically what that means is, let's say you run your estimate, you find your new EV is -2, then you'd simply go -2 divided by, subtracted -2 minus the -2.4 divided by the -2.4, and that would give us a margin of error of 18%, which would be pretty bad. And then the way that (0 to 33%) you're going to convert to 0%, 33 to 67% you're going to convert, and I don't mean 33.33, just plain old 33%. You can convert to 50%, and then 67%. Convert to 100%, but you know, 33.01 and 67.01. Just, you know, if it's 67, you'll count it as 50. If it's greater than 67, you'll count it as 100. So I would like you to do that and come up with the new EV. So before we conclude, today's Excel tip of the day will be the goal seek function. But the beauty of goal seek is that it'll give us, in poker, it can give us a break even, either pot equity or fold equity. So for this particular example, we want our EV to equal 0. We want to know how much fold equity we need for the EV to equal 0, so that we can just stop here, say, all right, this is profitable, that's it, don't have to worry about it. So there are a couple of things that need to be true for this to work. We need our variable, which is our fold equity, to control the EV, which it does here, but we also need everything to we need this to be a constant. We need this to be a number, as opposed to, you know, being tied to this, which is tied to this. That's not, or this, I mean, that's not good enough for us. We need to just have a number, because so it can change the number and not change the formula. So, you know, in less confusing terms, you know, let's say our folds are 50% here, and we need this to, obviously we need this to work as well. So you can change that around. So no matter what, if we change the folds to 60, the calls will go down to 40. If we change the calls to 70, if we change the folds to 70, the calls will go down to 30. That's good. That's what we want. And the EV changes as a result. So what GoalSeek is going to do is, it's basically going to do a trial and error. It's going to keep messing around with the fold equities until we get an EV of approximately 0. So we go to Tools, GoalSeek. First is our formula cell. That's usually going to be our EV. And then what do we want our EV to be equal to? In most cases, it's going to be 0. But sometimes we've determined that the EV of calling is 2. As a result, we'd want the EV to equal 2, because we'd want, you know, check raising to be equal to or better than calling. Hopefully that's simple enough. And then our variable cell is what do we want changing around? What's the break even thing we're looking for? We're looking for break even fold equity here, so we're just going to change around our fold percents. And it gives us our answer, and we can have it plug it into the cell. And there we go, 60.2% yields an EV of 0. It gives us the exact percent that needs to be true. And now we can, you know, sort of backdoor it, and we can say, all right, well, we have 55%, we need 60%, and you can start playing around with the range. You know, how often does he have to fold different hands in order for us to have, you know, sufficient fold equity? So that will conclude this video. I think this is a good place to stop, and absolutely continue with this example, and hopefully be, you know, more interesting now that we've got pretty much all the skills necessary to solve a poker problem. Now we'll get to, you know, solving some real poker problems in future episodes. So thanks everyone for watching, and this has been Josh for Deuces Cracked.